Hi students, in this video we are going to discuss what is an acidic compound, what is an basic compound, and how do we measure the acidic nature and the basic nature, and how do we relate them in our day-to-day life. And we are going to learn about the most important topic, that is about the pH scale. Yes, now let us start beginning our video with the basic what is meant by an acid, what is meant by a base. Yes, let's get the definitions of the meaning of acids and bases. Prior to that, there are many theories that explain about the acidic nature and the basic nature. The one and the most theory is about the Arrhenius theory. He was the Swedish scientist. He explained about the acids and bases in his theory. In our previous video, we had discussed what are the properties of acids and also what are the properties of bases. In this video, we are going to give the definition of the acids and bases according to the Arrhenius theory that was proposed in the 1887. So, what is an acid according to Arrhenius? Let us take a simple example. When you are having a half piece of lemon in your hand and you try to squeeze it on your tongue, do you feel how the taste is? Yes, the acids are so to taste. And now the same remaining half that of the lemon you have, you squeeze it in the glass of water and you mix it with the water and add 3 spoons of sugar, that makes your Nimbu Pani. In which case you feel the condition is more acidic. Yes, when you directly take an acid on your tongue, there will be a little moisture, so that acid of the citric acid will dissociate into ions and you feel it is more acidic. But once you squeeze it into the water, you feel it is less acidic. So what is meant by an acid? Means acids are the substances that dissociates into ions to produce the H plus ions. What are the acids? According to the Arrhenius theory, acids are the substances that dissociates in which presence, means in water, to yield the H plus ions. We had already learned in the grade 9th standard the atoms that are having a charge, maybe a positive charge or negative charge, they are called as the charged ions. So here the definition how we give is acids are the substances that dissociate in water to yield electrically charged atoms or molecules, they are called as the ions. Acids are readily giving which kind of ions, children? H plus ions. If you take an example, that is called HCl, hydrochloric acid. When you dissolve the hydrochloric acid in water, it will dissociate to give H plus ions and the Cl minus ions. So what ions were generated here? H plus ions and the Cl minus ions. So we must not forget that the acids are readily going to give the H plus ions. And let us take some other examples for the acids. By comparing in the form of diagram, the HCl that we had studied previously, the size of the cation will be very small, that we had learned in the grade 9 standard. And the size of anion, what is anion? The negatively charged ion is called as the anion. Generally it will be very large in size. So these cation and anion of hydrochloric acid are dissociating in water to give the chloride ion and the H plus ion. The water which is having the formula H2O It consists of three atoms, a hydrogen bonded to the oxygen and followed by another hydrogen. Means what we speak is the three atoms of water, the H2O, that is also dissociating basically to give OH minus ion and the H plus ion. So can we could say water is also an acidic in nature because it is giving H plus ions. So it is also going to act like an acid in the normal conditions. But what happens when you dissolve the HCl in water? When you dissolve the HCl in water, the H plus ions that are released by the hydrochloric acid will be gained by the H2O molecule to form a 4 atom containing ionic compound, that is H3O plus. We are going to call it as the hydronium ion. What is it called, children? Hydronium ion. So what ion is generated when an acid is dissolved in water means we will be saying H plus ion, and it is contained together as the hydronium ion because it is combining with water to form the H3O plus ion. So let us take what is the main theme of these acids. The acids are going to present the H plus ion. Now the number of H plus ions that are given by an acid is called with another name known as the basicity of the acid. What do we call as the basicity of the acid? So what is meant by the basicity? Previously we had seen hydrochloric acid had given how many H plus ions? Only one H plus ion. So the number of H plus ions given by an acid will decide its basicity nature. Let us give the definition of the basicity first. What is meant by the basicity? Please observe there. Basicity of an acid is the number of hydrogen ions which can be produced when one molecule of acid is dissociated in water. One molecule of acid is dissociated in water. So can you decide the basicity of hydrochloric acid, children? How many H plus ions it is giving? It has given only one H plus ion. So it is called as the monobasic acid. What is it called as the monobasic acid? Now if I take the H2SO4 sulfuric acid in water, when it is dissociated, it forms 2 H plus ions. Now can you say what is the basicity of sulfuric acid? Yes, we had known about the basicity, means the number of H plus ions given by an acid is called as the basicity. Here how many H plus ions were given by the sulfuric acid? We are able to see it had produced 2 H plus ions. So what is the basicity of sulfuric acid? We can say its basicity is 2. Yes. Now can you go for the example number 3, that is called HNO3 or the nitric acid. When nitric acid is dissolved in water, how many H plus ions were generated? Can you observe? It had produced only one H plus ion. Means what is its basicity? Its basicity is called only 1. So we had known what is meant by an acid now and what is called as the basicity of the acid also. Now let us go with the next content. How had we classified these acids? In the previous video we got some precaution. Which acid can be tasted, children? Yes, we can taste the organic acid, but we must not taste the inorganic acid. What is an organic acid? Yes, the acids that we have in our chemistry lab. are called inorganic acids, but the acids that we use regularly in our home, like the lemon juice, citric acid. The lemon juice contains the citric acid. We are using in preparing various dishes with the lemon juice because the lemon is also containing hydrocarbon in it. The acids that contain carbon in their constituent are called as the organic acids. So these acids that are containing carbon in their constituent are from the plant or animal products. The citric acid that we observe in the lemon is taken from the lemon plant, it's a plant product. These are the acids that we are using day-to-day life, in our day-to-day life, and they are not harmful for us. So we call them as the weak acid. But the correct definition I'll give again. In the lab, the acids are very strong, means once we place them on our skin, they are highly corrosive. So I want to call them as the strong acids. Those acids that we have in our lab, like hydrochloric acid or sulfuric acid or nitric acid, had you observed that they had any carbon constituent in them? No, we hadn't seen any carbon constituent in the sulfuric acid or nitric acid. These are called as the inorganic acids, means they does not contain carbon constituent in them, or they are also called as the mineral acids. Now let us give the clear definitions. What is meant by an organic acid and what is meant by an inorganic acid, and let's take some examples on these acids. So let us see about the organic acid. We had already discussed the organic acid is an weak acid. Why is it called an weak acid? What is an acid? First of all, acids are the substances that produce H plus ions. Now we had classified the acids into two categories, organic acids and the inorganic acids. These inorganic acids the organic acids are not harmful for us, so we use them in our day-to-day life, in our home so-called dishes that we use, because they does not dissociate into H plus ions readily. Organic acids does not dissociate into H plus ions readily, or in another word, they give very less number of H plus ions. So they are called as the weak acids. Where are they obtained from? We have discussed. They can be obtained from the plant or animal products. What is the constituent in the organic acid? They contain an organic compound. Organic compounds are the one that contains carbon as their major constituent. Carbon as their major constituent. So give the definition of the organic acid is: an organic acid is an organic compound with acidic property. An organic acid is an organic compound with acidic property. We have discussed about the organic acid definition now. Let us take up some examples. How many of you like noodles? Yes, when the noodles are being prepared, do you observe it was added by a little amount of vinegar in it? Yes, the vinegar, when they add, that gives a little taste because it increases a little so to taste for the vinegar. Had you observed what is the vinegar or where is it from prepared? Yes, it is prepared from acetic acid. It is prepared from acetic acid. Now let us take many examples now from the sources of organic acids, then we can come across. Yeah, some of the examples of the various organic acids, we had the source here in one column and what is the acid generated here. So here the first example what we got is the vinegar. The acetic acid, vinegar contains the acetic acid in it. Do we know where did we get this acetic acid from? See, we had already discussed the point. We are using the acetic acid in the noodles. Acetic acid is generally extracted from acetic acid bacteria. What bacteria? Acetic acid bacteria. There are two kinds of acetic acid bacteria here. One of that you are able to observe in the diagram, that is called Acetobacter, and another one is called Clostridium acetobutysalium. These are obtained from the foodstuffs and the water and the soil. So this is the source for the acetic acid, and that is what we are using as the vinegar. Where did we use vinegar in our day-to-day life? We said we are using vinegar in the preparation of the noodles that we had observed. Other than that, where do we use the vinegar? We use the vinegar in preserving pickles. Yes, they use the vinegar in the preserving pickles. Do you remember the lemon juice that you had cutted half and taken into a glass of water? See, in the glass of water approximately there will be 200 ml of water, yes or no? And you may have added only a 5 ml of the so-called lemon juice in it. It produced the lemon juice for you after adding a squeeze of lemon. Similarly, when you are going to take 92 ml, when you are going to take 92 ml of water and add 8 ml of acetic acid for it, it is called as the 8% of acetic acid. This is a diluted acid we call. So we had given the name called as the vinegar. At times we may use 95 ml of water and only 5 ml of acetic acid. So it may be from any range. We can use 5 to 8% of the solution of acetic acid in water. So this solution of acetic acid in water we are calling as the vinegar. What are we calling as the vinegar? Where do we use this vinegar? We use it in the preservation of pickles and also in the preparation of the noodles. This is the first organic acid that we got in our tabulated data. The second organic acid, when the curd is left for one more day, it becomes too much sour, because in that the acid that is generated is the lactic acid, and the orange or the lemons, then we see they contains the citric acid in it, and also the tartaric acid is extracted from the tamarind, which makes the dish delicious for you. And the tomato, it is containing oxalic acid in it. Whenever any red ant bites you, do you feel some pain? The same thing you can experience when a nettle injects the sting into your body. In both the cases, that is when a red ant bites you or when a nettle just injects the sting in your body, they both inject an acid into your body that's called methanoic acid. We will be dealing this topic in detail later. Presently we are just learning only the names. So these are the acids that are obtained from various sources. This all contains carbon as one of their main constituent. So these are called as the organic acids. Up to now we had discussed that the classification of acids based on their source, there are two kinds of acids. What are they? Organic acids and the inorganic acids. Now we had seen something about the organic acids. Now let us see the inorganic acids. These inorganic acids does not contain carbon as their one of their constituent, and they are readily producing H plus ions when dissolved in water. So they are called as the strong acids. What are they called as the strong acids? They have generally a H plus ion and a conjugated base. Means the base is the one that bears a negative charge here. We will be discussing what is meant by a base first of all. Up to now we have discussed what is meant by an acid. What is meant by an acid? The acid is the one that produces H plus ion. But what is meant by a base? Let us see what is meant by a base. According to the Arrhenius theory, what is an acid? Acid is the one that produces H plus ion when dissolved in water. Similarly, according to Arrhenius theory, base is a substance that will give H plus OH minus ions when dissolved in water. These OH minus ions were called as the hydroxide ions. What are they called as the hydroxide ions? So let us give the definition here. Bases are the substances that dissociate in water to yield electrically charged atoms or molecules called ions, one of which is a hydroxide ion. Let us take one example here. When you dissolve a substance called sodium hydroxide in water, it will dissociate to give Na plus aqueous. Aqueous means the ions that are mixed with water, and also OH minus aqueous means the compound that was able to give hydroxide ion. Can we call as a base? Yes, we can call it as a base. So sodium hydroxide is one of the examples for base. Let us take few more examples of the bases. Can you could observe here KOH. It is called potassium hydroxide. When it is dissolved in water, it is dissociating to K plus ions and also OH minus ions. So the OH minus ions generated compound is called as a base. So potassium hydroxide is also called as the base. Next example is our magnesium hydroxide. Can you could balance the equation here, children? MgOH twice had given rise to. Magnesium is a divalent ion, 2 plus ion. OH minus. In the simple bracket on the reactant side we had twice, but I didn't balance it here. It's your work to balance. How many hydroxide ions will be generated here? 2 hydroxide ions will be generated. Previously, when we are learning about acids, we had discussed the number of H plus ions given by an acid dissociates or describes its basicity nature. Basicity, the word we call as the basicity. Now the number of OH minus ions given by a base explains about the acidity of a base. It explains about the acidity of a base. So what is meant by the acidity of a base? Please observe there. Acidity of a base is defined as the number of ionizable hydroxide ions present in one molecule of a base. See, there is a word correction here. It's not hydrogen ions. It is hydroxide ions present in one molecule of a base. Can you could explain what is the acidity of potassium hydroxide? Yes, potassium hydroxide had given how many OH minus ions, children? Only one OH minus ion. So shall we call its acidity is 1 monoacidic base. Now what is the acidity of magnesium hydroxide? In this you must balance the equation. The acidity of magnesium hydroxide is 2 because it had given 2 OH minus ions. So it's a diacidic base. Now let us come back to our acids topic that we had started. Our acids, there is the mineral acids. They are strong acids we mentioned. The mineral acids are the strong acids that give H plus ions. We had learnt about these all acids, so I had skipped the slide, that's called HCl, H2SO4, HNO3. What is the acidity or basicity of the HCl? Monobasic acid, H2SO4, dibasic acid, HNO3, monobasic acid. So this basicity and acidicity you must be learning to understand the number of H plus ions and also to understand the number of OH minus ions given by the bases. Now, how strong are the acids or bases? We need to know, we had explained that the acids are called strong acids and they are also called weak acids. And how can we depict that this is a strong acid, this is a weak acid? All the acids are able to give H plus ions, but the strong acids give readily the H plus ions, but the weak acids are able to give are not readily able to give the H plus ions readily. So based on this topic, we got this very important question, that is, how strong are the acid or basic solutions? Whenever we get the word solution, it means the acid is dissolved in water or the base is dissolved in water. After dissolving in water, what do the acids give? The acids will give H plus ions and the bases are going to give OH minus ions. Now this is our main key concept for this entire chapter. The strength to give the H plus ion, the strength to give H plus ion is called the pH. What is it called as the pH? It's called potence of the hydrogen ion. What is it called as the potence of the hydrogen ion? Yes, we got the first slide on this one. Now we are getting how to define the strength of the acid or base. Please observe the pH scale. It is not the 15 centimeters or 30 centimeter scale that we use in a regular life. We have a particular pH scale. This pH scale we range from the value 0 to 14. From where to where is the pH scale ranging from? The pH scale is ranging from 0 to 14. Whenever we have the exactly 7 value, we are going to say it is an neutral substance. What is it? An neutral substance. But the compounds that are going to have the nearer to 0, can you could observe the above diagram, children? The blue color line that is having more H plus ion concentration, and the white color it is going to explain there are more OH minus ions. Means when you come to the 0, the white color is very less. It is indicating there are no OH minus ions, but it is indicating there are more H plus ions. We had already discussed when the H plus ions are given readily, they are called as the strong acids. Means when you are coming for the 0, it shows that it is a very strong acid. 0 to 6.9 is the exact value we must take as an acidic compound, and lesser the value that is coming to 0, it is more acidic. When you are reaching to 7, the H plus ions will be given very less, so this is an weak acid. Coming for the value above 7.2 to 14, that is 7.1 to 14, we can say the value that ranges from the 7.1 to 14, here what is decreasing? H plus ion concentration is decreasing, whereas the OH minus ion concentration is increasing in the solution. That is, the bases that are soluble in water to give OH minus ions we call as the alkalis. So come to the final conclusion. In the pH chart or the scale, we have the value ranging from 0 to 14 and also exactly 7. 7 means the exactly neutral compound. So when you come to 0 value, that will give more H plus ions. So they say there should be strong acids, when you come to nearer to 7 from the 0, the H plus ions are decreasing, so they are the weak acids. From 7.1 to 14, once you go on, the OH minus ion concentration is increasing. Means when you go to 14, the compounds are said to be more basic. The compounds are said to be more basic. So this is what we call as the pH scale. So come to the conclusion of the graph that we are discussing now. On the pH scale, we can measure the pH generally ranging from 0 to 14. What are the compounds at 0 we call? They are very acidic. And at 14, what do we call? They are very alkaline. Alkaline means they are very highly basic. And the pH, whatever it may be, the lower the pH, means when it is 0, we say it is the strongest acid, and higher the pH, it is the strong base. In our day-to-day life, whenever we dissolve any acid or base in water, it will form a solution. Yes or no? Yes, that solution we can check how much is it having the pH. But we cannot study the numbering every time. It can be studied using an electronic device. That is the pH electrode. But without using the pH electrode, we can also measure by taking some colors as the reference. By taking some colors as the reference for the pH values. So this coloring is given by a mixture of various indicators. We had already learned about some indicators. Now we got an indicator called universal indicator. What is indicator called? Universal indicator. Can you could observe this indicator, children? Yes, I am getting it above, yeah, to the right side. Good. The pH chart we can call, it is shown by the universal indicator. Means whenever you have the pH value 1 and you had added or you had dipped the indicator or the liquid, this indicator, into a substance, if it shows red color, then you must define it is pH is 1. And you had got a solution, into that you had added the universal indicator drop. This is also a liquid. Universal indicator is also a liquid. Then if you get a pink color in your container, you can say the pH is 2. Similarly, the 3 means orange, 4 big, 5 yellow, 6 lime green, 7 green, 8 dark green, and so on colors you can find. So based on a particular color that we obtain in the container, after adding, first of all we are going to take a container. In that container we will take any solution. It may be acidic solution or basic solution. For that we are going to add the universal indicator, a drop. Then we observe the change in color. By referring these colors, we can say what is the pH of the solution, and we can say whether it is a too strong acid or a weak acid, or it is an weak base or a strong base. Some examples that we got along with us is, now we can observe here at the 0 we are having the battery acid. Battery acid means that is the acid we use in the battery, sulfuric acid. And in our stomach, in order to digest the food that we have taken, that is going to release hydrochloric acid. The hydrochloric acid ranges in the pH of 1.2. We will be dealing in detail again. And you can see the lemon juice, its pH value ranges with 2. And also the vinegar, its pH value ranges with the 3. In the tomato, it's 4. Coffee 5. Milk 6. Can you could say now milk is also a acidic compound? Yes, it is an acidic compound, but very weak acid. Let us get a very important question. Why do milkman will add a base into the milk in order to preserve it? Yes, we will learn about these questions later in the next video. And now you can see the blood in our human body, it is having a pH of above the 7. that is nearer to 7.8 generally I take. Means can we could say the blood is having a very light pH, that is in the basic nature. I don't say light pH, it is a slight basic in nature. So we can observe at the 10 there are some stomach tablets they mentioned. What are these stomach tablets? The ENO that we use after having a heavy food. The ENO is a basic compound that will neutralize the excess of acid generated in our body. That's what we call the milk of magnesia. Another example, these are all called stomach tablets. The soap that we use in our day-to-day life, it is also a basic compound. And the bleach that is used to bleach up the compounds. These are all the many examples that we come in our day-to-day life that are related to the pH scale. So let us come to the conclusion. What is pH scale? pH scale is used to measure the strength of a substance to produce H plus ion. The pH scale is to measure the strength of the H plus ion. How is this pH measured? It is measured using an universal indicator. It is having different colors. So in the next video, we are going to see how are we going to study the pH in our day-to-day life and how is it related. Thank you, children.